So we're finally going to get into insulation, but we got a little more theory. But I think this is also maybe ninth grade science class that we're going to go back to. Okay. So right here I have a picture of the three methods of heat transfer that I want to talk about a little bit here. So this first one is conduction, okay, and that is heat transferring through solid materials. Okay. We've got convection. That's heat moving through liquids or gases. And we've got radiation. That's heat traveling through infrared light. Okay? The sun heats with radiation. Okay? So first thing we need to establish, okay, and this is kind of a technical thing here, it's kind of silly, but there really is no such thing as cold when we're talking about thermal transfer. Okay? There's just heat, and it's on a scale. Okay? There's more heat and there's less heat. Okay? And on that scale, heat is always going to try to equalize. Okay? So heat is going to want to move from warm places to cold places, and from cold places to warm places. Okay? Or, to get technical here, it wants to move from areas of more heat to areas of less heat, and vice versa. Okay? And this is a rule that will be very helpful in understanding potential moisture problems, but the warmer the air, theoretically the higher the moisture content. Okay? Warmer air can hold more water than colder air. Okay? Condensation is a really easy way to visualize that. Okay? We've got a cold window, it's warm inside the house, that warm air inside the house hits the cold window and condenses on that window. Okay? Same thing, we're standing outside holding a cold can of Diet Pepsi. That warm air is going to condense on that can and leave liquid water behind. Okay? All right. The other thing we have to understand is that when we have two different objects of different temperatures contacting each other, meeting in some way, heat flow is going to occur. Okay? Heat is going to make its way through those materials. It's unstoppable. We can never stop it, but we can slow it. Okay? We can slow it a couple of different ways. What kind of materials we're using to slow that heat transfer. Okay, different materials have different R values. We'll talk about what that means in a little bit here. But also the thickness of materials. Okay, if we build a 16-inch deep wall and stuff it full of insulation, it's going to take a lot longer for that heat to transfer through that wall. Okay, that's called thermal mass. All right. Most of these insulating materials, the way they work is by trapping little pockets of air. Okay, and those little pockets of air slow thermal conduction, slow thermal transfer. Okay, they can also, a lot of these insulating materials have the side benefit of inhibiting or slowing the movement of sound waves. Okay, one of the huge benefits of exterior insulation is making it so much more quiet in the house. Okay, and then the last thing I want to just kind of touch on is air, as well as heat, is going to move from areas of low pressure to high pressure. Okay, and vice versa. Air, as we've established, has the potential to contain moisture. It also has the potential to be carrying heat with it. Okay, think of the attic as a perfect example. Okay, if it's nice and cool inside our house and it's really, really hot inside the attic, and we have a leaky ceiling and we didn't seal up the can lights or seal up the plumbing penetrations, that air from inside the house is going to leak up into the attic. Okay? If we're losing air from the house up into the attic, that air is going to be replaced somehow. Okay, and then it's going to pull air in from the outside. Okay, what that's called is either a convective loop or the stack effect. And we'll talk a little bit more about that. All right, first on the list is conduction. Okay, we'll go a little deeper into this. And like I said before, conduction is the transfer of thermal energy through solid materials. Okay, so as it relates to our house, our walls are going to be a certain temperature. Inside the house is going to be a certain temperature. Outside the house is going to be a certain temperature. These two want to equalize, and they're going to move through the wall. Okay? So if the wall is 78 degrees out here, and the wall is 65 degrees in here, these two are going to equalize, okay? And then there's going to be a constant flow of heat, constant conduction, thermal transfer, okay? Same thing's going to happen with windows, same thing's going to happen with the floor, same thing's going to happen with the ceiling and the roof, okay? The way we counteract that generally is by placing some kind of insulating material in the cavity. Okay, and that's traditionally been the way that we've done it since the 50s. And we're starting more and more to put insulation on the exterior of the house also. Okay. The problem with just using cavity insulation is that every single stud in that wall is a thermal bridge, and it doesn't have the same insulating value as that cavity insulation. Okay, so it's going to conduct heat much more readily than the cavity. Okay, wrapping the house in exterior insulation is going to dramatically slow that thermal conduction. All right. Like I said before, one really easy way to up the insulating value of your house is to make the cavity bigger. Okay. One of the first things we did with the CR houses when I took over is we switched from 2x4 construction to 2x6 construction. The only reason, because we could get thicker insulation in the walls. Okay, so here's a diagram showing like a 2x4 wall, 16-inch on center, showing how much insulation material you're able to get in versus a 2x6 framed wall, and you get 57% more insulation inside that cavity. It's a dramatic difference. Okay, it is. I would just say it's very, very difficult to build with 2x4 walls anymore. Somehow people are still kind of getting away with it. I'm not entirely sure how. They're not supposed to, from what I've been told, but 2x6 walls aren't that much more money. It's so much easier for the plumbers. They love having the room to be putting pipes in. It's so much better for the electrical trades, heating trades. Everybody's able to get more stuff in the wall, including more insulation. Okay. One thing that I think I mentioned earlier that people don't quite understand is that there can still be convective thermal transfer through some of these insulating materials, particularly fiberglass bats. Okay. If you don't properly air seal the exterior of your house, or underneath the wall, or in the ceiling, or around receptacles and stuff like that, air is going to move through fiberglass pretty readily. Okay. This staining right here, this is showing you that this insulation is acting like an air filter. Okay. Air is moving through this material and leaving dirt behind. Okay. It's a big old air filter. Okay. Which I guess is nice, but this is just showing you that some better air detailing should have been done on this house. Okay. Because if you have air moving across fiberglass insulation, the reduction to the R value can be up to 50%. Okay, so it can be a very dramatic reduction in the R value. And when we talked about convection, you'll realize that that has just as much to do with comfort as the actual temperature of the house or the temperature of the walls. Okay.